Hello everyone, I'm Sudhanshu Sarkar, Assistant Professor, Department of Electrical Engineering, Narula Institute of Technology. Today I'm going to talk about a topic of electrical circuit and network. Electrical circuit and network subject is designed for second year diploma electrical engineering students. So here the lesson plan. I will complete total 3 unit 2, 3 and 4 for this particular subject. And today's topic of discussion is the phasor diagram and impedance triangle of series RC circuit. In my last few lectures, I already talked about what is RC circuit, how to find different elements from RC circuit. So these are the topic was there for that lectures. Today, my main aim is to show you that how to draw the phasor diagram from a RC circuit and impedance, how to develop the impedance triangle of a series RC circuit. So for that, first we have to select a circuit which is a series RC circuit. So in series RC circuit, there is a resistance R and a capacitance C. So here, if you follow, you can find that the resistance is R and the capacitance is C. The voltage across the resistor is VC and the voltage across the VR and the voltage across the capacitor is VC. And the supply voltage of this circuit V equals to Vm sin omega t. That means AC supply is there in this circuit. And also it is written here VR is the voltage across the resistor R, VC voltage across the capacitor C, and V the total voltage across the RC series circuit. So first we have to consider a series RC circuit, and we already considered a series RC circuit, and this is the elements and the meaning of all the part of this circuit. Now this is the process that how to draw the phasor diagram of a circuit. It is very simple. To understand the process, you need to remember 2-3 steps only. That is sufficient. So what are that 2-3 steps? So that 2-3 steps is the first step to draw the phasor diagram of RC circuit. The first step is take the current, obviously the RMS value of the current, as a reference vector. So what we have to do first, we have to consider current I as reference vector. So here we consider x-axis as our reference axis, and along x-axis we consider the current as our reference vector. So this is step 1. Now move to step 2. What is step 2? Step 2, voltage drop in resistor VR. So this is actually suffix R. So VR is equals to IR. So this is the VR equals to IR, voltage drop in resistor resistance VR equals to IR. This is suffix. So VR equals to IR is taken in the phasor with the current vector. So we are taking VR, that is equals to IR, which is taken in the phase with the current vector. That means VR is along x-axis. So VR and current are in the same axis. Now step 2 is also completed. Now move to step 3. What is step 3? Take a look about step 3. Voltage drop in capacitive reactance Vc equals to Ixc. You already know these. Vc equals to Ixc. Actually, this Vc is V suffix C, that is equals to the current across the circuit, and X is the capacitive reactance. And we already know that the voltage drop across the capacitor is Vc, and that is equals to Ixc. Is drawn 90-degree behind the current vector. So we draw it 90-degree behind the current vector. So where we draw it, take a look of that. So we draw from this position. This is the current vector. This is the voltage drop across C, or you can say the voltage drop across the capacitor vector, Vc vector. So it's drawn 90-degree behind the current vector. So this is actually 90-degree. So why it is behind? Because we know that this direction is called the clockwise direction and this direction is called the anti-clockwise direction. So if some phasor position is clockwise direction, then from the reference phasor we consider that that phasor is a lagging phasor, or you can say behind phasor, as current leads voltage by 90-degree. And we know that for a purely capacitive circuit, current are always lead 90-degree from the voltage. So in other words, we can say that if this is the voltage phasor, then this will be the current phasor. This is the voltage phasor. This one is the voltage phasor. So this one will be current phasor. So you can explain this term in two ways. One, voltage is lagging behind current, or you can say capacitive voltage. The current is leading from the capacitive voltage. Both are same. So this is step 3. Now go to step 4. The vector sum of two voltage drop is equal to the applied voltage V. So which one is the voltage sum of two area? Look, this is VR vector. This one is VC vector. Because if this part is VC vector, so this one is also will be VC vector. So the vector sum of two vectors, so vector sum of VR and VC is equal to the applied voltage V. Equal to the applied voltage V. Now we know that VR equals to IR and VC equals to I of XC. So this is actually VR. V into R, not suffix R. So VR equals to IR. This is the voltage drop across the resistor, and VC equals to IXC, voltage drop the capacitor. where xc we already know x equals to 1 by 2 pi fc. So in this way, we can draw the phasor diagram of series RC circuit. I think now you all are clear about this. Next, we are going to find the impedance, or you can say that if you have to find the current of this phasor, then how to find it. For that, we need to consider OAB triangle. So right triangle OAB, if you follow, using the Pythagoras formula, we can say that OB square equals to AB square plus OA square. That means V square equals to VR square, V square equals to VR square plus VC square. That means V equals to root over VR square plus VC square, which is written here. V equals to root over VR square plus VC square. Now put the value. What is VR? VR equals to IR. What is VC? VC equals to IXC. So V equals to I into root over R square plus X square. Because root over I square is equals to I. So we can write in the simple form V equals to I root over R square plus X square, or we can say that I equals to V divided by root over R square plus X square. That is equals to V by Z. So what is Z? Z equals to root over R square plus X square. So in this way, we can find the impedance or the current from the phasor of a series RC circuit. Now, let me talk about the phasor diagram. From the phasor diagram shown above, so this is the phasor diagram. What is shown here? Some angle is there between VR and V. Shown above, it is clear that the current in the circuit leads the applied voltage. The current in the circuit leads the applied voltage by angle phi. So go to the slide. So current leads the applied voltage by an angle phi. I think it is clear to all of you. So current is actually leading because the position of current from the applied voltage is anti-clockwise. So current is leading at an angle phi from the applied voltage. And this angle is called the phase angle. So how to find this phase angle value? This is very simple. So if you follow this circuit, what is tan phi? Tan phi is VC by VR. This is VC, the height, VR, base. So you can find tan phi equals to VC by VR. So that is written here, VC by VR. What is VC? VC equals to IXC. What is VR? IR. So just omit I from here. So we'll get XC by R. And finally, we can say that phi equals to, from here, tan XC by R. Okay. So in this way, we can easily find the phase angle of series RC circuit. It's very easy to understand. You have to go through a few books, and if you read seriously, everything will be clear within few days. Now, the second topic for today's lecture, that is the impedance triangle of series RC circuit. This is very easy. You already learned it from the previous lecture, from this part of this lecture. Look very carefully. What is the phasor diagram? Phasor diagram of this part, OAB, right angle triangle. You can say that this is a voltage triangle because this is VR, this is VC, this is V. Voltage across the resistor, voltage across the capacitor, and the applied voltage. So draw the figure again. So if you draw it, what you will find? Look, this is our VR phasor, voltage across the resistor. This is VC phasor, voltage across the capacitor. This is V, the applied voltage. Now tell me what is VR? You all know that VR is nothing but IR. What is VC? This is nothing but IXC. And what is V? The supplied voltage or applied voltage, V into Z. So we just write all the voltage equation here in this phase, along the phase. Now the next job, just remove this V and I. Just remove this V equals to N to Z. Just remove this part. So what are the other part? Now the remaining part of the axis. This is R. Along this is XC, and that one is Z. So it's a right angle triangle now. So in this way, we can develop the impedance triangle of a series RC circuit. So as per the Pythagoras, we know that Z equals to Z square equals to R square plus X square. So we can say that Z equals to what will be Z? That is equals to root over R square plus X square. So this is the process and the mathematical modeling of impedance triangle of series RC circuit. If anyone have any doubt regarding this phasor, how to draw the phasor diagram of series RC circuit and how to develop the impedance triangle of series RC circuit, please let me know so that I can again clear the concept to all of you. Now this is the waveform and power curve of RC circuit. So if you follow very carefully, you can find that this one is the power waveform. The red color is the current waveform and the blue color is the voltage waveform. Three different waveform is here. The various point on the power curve are obtained from the product of the instantaneous value of the voltage and current, because we know that power is actually the product of voltage and current. The power is negative between the angles. So where power is negative? Look, try to understand this. in which part power is negative. Okay, look, this is the power curve. So this portion, the power value is negative, and also which part? This part, the power value is negative. So we can conclude that the power is negative between the angle 180 degree minus 5, 180 degree minus 5 and 180 degree. So this region, if this is 5, 180 minus 5 and 180, and where this place, the power is negative between 360 minus 5, 360 minus 5 and 360. And in the rest of the cycle, the power is positive. Yes, obviously. Look, this part is positive. And here it is positive. This is also positive. Up to this. From here it is positive. From here it is positive. So the rest of the part, you can say the power is a positive. Since the area under the positive loops is greater than that under the negative loops, yes, obviously, because the positive waveform value is more than the negative area. Therefore, the net power over a complete cycle is positive. So, what will happen? The net power over a complete cycle will be positive for series RC circuit. I think this part is also clear to all of you. And if you follow carefully, you will be able to understand that. Tell me, current lag or lead for RC circuit, series RC circuit? Current lead. That means voltage. So how current is leading here? Look, the voltage waveform, we know that V equals to Vm sin omega t. Blue color is the voltage waveform. So at that point, current is already leading at an angle phi, because at this point, 0 point, the value of voltage starting 0, but here already it has some angle. This is the point. It has some value. So for that reason, we write I equals to Im sin omega t plus phi for RC circuit, where V equals to Vm sin omega t. This is the supply voltage. So what will be the current waveform for RC circuit? Because current lead, so I should be equals to Im sin omega t plus phi. Sin omega t plus phi, because the current is leading from the voltage for RC circuit. But for RL circuit, current will lag behind the voltage. So for that case, omega t minus phi will come for current. Both the cases, the voltage is equals to Vm sin omega t. This is the part. I think it is clear to all of you now. So to make this PowerPoint presentation, or and after that, for recording purpose of video lecture, I take reference from this particular, take help from this link, website link. Now, thank you everyone for watching this video. Thank you.